Alright, so today's problem's name is largest divisible subset, and given a subset of distinct positive integers, find the largest subset such that every pair of elements in this subset satisfies this condition, either the element at j divides s or the element at I divides j. So this is the condition in a subset that you can say, or in a pair that you can say as Si of Sj. This condition should hold, and if there are multiple solutions you can return any of the subset and that is fine. Alright, so and this condition is also there, largest subset, the subset should be largest. Okay, so like for this 1 2 3, 1 2 and 1 3 both are subsets, so you can return any of the two. So pretty simple problem and not so easy to solve. So let us see how we are going to do this. I have taken a nums array as an example. Okay, so we will be given something like this array. Okay, and the first thing that we'll do is sort this array. Alright, so this is the sorted array. I have taken it here. So I'll be applying depth first search on this array, and we have a subset array that will help us in knowing whether the current element is already a part of some previous subset or not. Alright, so this result will store the list that we have to return. Okay, finally, and this current list will be our current list as according to its name. So let's start from the first element. So 1 is initially not visited and it is not a part of any subset, so that is why the value is -1 initially. Okay, so we will start from 1. Alright, so we'll add 1 in the current list and we will make a recursive call to the next element. Also make this value as 0 because 1 is visited now. So now 1 as being the previous element, can 1 divide 2? Yes, because you can see that 2 mod 1 is 0. So 2 will be added in our list because 2 is divided by 1. Okay, so our current list will have 2 now, and also the value here will be 1. Alright, so 1 is added here because you can see that 2 is now a part of a list or a subset which already has a 1. Okay, so it is a part of a list that is of length 1, so that is why I have added 1 here. So things will be clear. Let's move forward. So with 2 as the previous element, we will make a next call, and that will be to 4. So 2 divides 4. Okay, so the first condition is met, and the second is we will see whether it is already visited or whether it is already in some subset or not. No, it is not. So what value I'll write here? I'll write 2 here. Why? Because 4 is now a part of list which is already of length 2. Alright, so I will add 4 in my current list. So up till here we are done. Now from 4 as being the previous element, I will make a next recursive call. So 4 doesn't divide 5. So 5 mod 4 is not equal to 0. So we'll retract back and we'll try the next element. So from 4 we'll try to get to 6, but you can see that 4 also doesn't divide 6. So from 4 we have made all of our recursive calls, so we have to retract back, and for retracting back I'll have to, first of all, I'll add this current list in my result. So 1 2 4 will be added in my list, and now I'll retract back from 4. So removing it from our current list because we have made all the recursive calls from 4. Now we are back on 2. Okay, alright, so now we have to look from 2. From 2, can I go to any other element? So I'll try the next one. No, 2 doesn't divide 5, so we can't go here. So I'll try the next element. So yes, 2 divides 6, and also 6 is not a part of some previous subsets. So the value that I'll be writing here is 2. Why? Because 6 is now a part of list that is already of length 2 because it contains 1, 2, 6. So from 2 we have made all of our recursive calls, and I'll add 6 here also. So now this list will be added here. So now our result will be 1 comma 2 comma 6, even though the length of both the lists were same, but 1 comma 2 comma 6 will override the previous one. Okay, so it is okay that we can return any of the list of maximum length. Alright, so from 2 we are done. So we'll retract back. Alright, so I will take first of all 6 out from here, and also all the recursive calls from 2 is also made, so I will make 2 also out from here. Now from 1, can we go to any other element? Yes, we can go to 4, but since you can see that 4 already has a value of 2 in this subset, so that means that 4 was already a part of some subset that already has a length 2. So if you will take 4 and then calculate the next ones, for sure the length of that subset will be less than that we already calculated. So this value was basically for telling that only, and since the value is greater, so we will not make a recursive call to 4 because 4 was already there once. Okay, so we can't go to 4, so I will try 5. So can we go to 5? Yes, with 1 as the previous element, 1 divides 5, and also 5 is not visited yet. Okay, so what value will I write here? I'll write 1 here, because 5 is now a part of list that already has a length 1. So 1 will be here, and now from 5 I'll try to go anywhere after it, but you can't go anywhere after 5. So retract back, take 5 out, and also you can see that the length of the current list is less than result, so we don't have to do anything and we have to simply take 5 back. Now from 1 we will try to go anything after 5. So from 1 we can go to 6, but 6 already has a length 2. It is already a part of some subset that is of length 2, so we'll not go there because the subset that was in which 6 was included was of bigger length, so we don't have to go there, and we will simply return our result, that is 1 comma 2 comma 6. So I hope it was clear, but folding recursion is always a bit tough. So I've tried to fold out and show you what our recursive code will do, and remaining things will be clear when we'll code. So let's just quickly code it out. First of all, I'll be declaring the list here, taking it as global variable. Alright, so it will be of integer type. And also one array subset. Okay, and inside this what we were doing, first we were sort the array, and after that it will be of same size of the array. Okay, we have declared this, and after that I will be filling all the index of this subset array with a value of -1. Fill. Alright, so I filled all the indexes with value 1, and after that okay, we are done with this, and after that I will be calling my helper function with passing the array and the starting index 0, the array list, and 1 as the previous value, and at last we will be returning result. That will be our answer. Right, so after that we will be writing our helper function and what all values we have passed, and array and index and an array list that is of integer. Okay, and that is our current list, and the previous value, which will check whether it divides or not. So this will be our helper function, and the first condition will be if our current list size is greater than result dot size, then this we have to make it as result. So result will be numeral list and that will be of current. Okay, so making this current list as result if its size is greater than the result, and after that simply looping through the array, and inside this we will be making our recursive calls. Okay, so the first thing that we want to check after coming inside is that two conditions. So the first one will be current dot size, it must be greater than the subset of that element. So why is it that? It's just for telling us whether it was already a part of some subset or not, and our current element must be divisible by the previous element. So these are the two conditions. If it satisfies, then we will be inside this if condition. So first of all, initialize the subset position with the list size, and after initializing it, add the current element in our current list, and after this make a recursive call to our helper function with the current array, the next index, current list, and the current element as the previous element to the next call. So yes, and after this is for backtracking. You need to remove the last element after all the calls, is -1. So this was the whole solution, and this was a bit tough to explain because generally unfolding the recursion is a bit tough to explain. I have tried my best. Let's see if it runs or not. Okay, accepted for the basic test cases. So yeah, done. So I'll see you in the next video.